we will look at a couple more examples of verified trig identities. So we're going to do the same thing as before to verify this identity. Remember, we're going to build a wall here so that we're not tempted to, do the same thing on both sides. And we're just going to go one step at a time. Take a look at that right-hand side. 2 times the cosecant of theta. It doesn't get simpler than that. I'm going to leave that one alone. The thing on the left, there's, a lot that I can do. So first things first, I've got fractions I want a common denominator. So I'm going to multiply by sine over sine on the left, and 1 minus cosine theta over 1 minus cosine theta on the right. Now, that means on the right-hand side in that numerator, it's 1 minus cosine theta squared. I'm going to have to FOIL that out, but that's okay. We know how to FOIL, especially foiling perfect squares. We spent so much time completing the square in the fall. We're pretty good at that. If you're ever asked to justify your steps, it just means naming the property that you used there. Because all we did was multiply both sides by 1, we will call that the multiplicative identity property. You're not often asked to justify your steps, but if you're certainly not all of them in the same problem. But it's good to be able to recognize the names when you see them, when you need them. Okay, well, because the two fractions are the same, I'm going to now combine them into a single fraction. Sine squared theta plus 1 minus 2 cosine theta plus cosine squared theta all over sine theta times 1 minus cosine theta. That's quite a mouthful. All right, let's see what we can do here. First things first, I want you to notice what you can. Remember that in the numerator, it's all just a string of addition, subtraction, and the order of addition, subtraction can be moved around as much as you want. So, for example, I could take this cosine squared theta and I could move it over there. All the other terms, make sure that you keep the signs the same, signs with a G, so that that negative 2 cosine theta stays negative. And if you're ever asked to justify what you're doing here, make sure you can say that, well, since all we did was we reorganized the order of addition subtraction, well, there's a name for what lets us reorganize things. That is the commutative property of addition. Okay. The reason we did that was to recognize, hey, we have a Pythagorean identity right there. Sine squared plus cosine squared is equal to 1. So that becomes 1. And of course, I can add 1 plus 1. And some of you may already see where we're headed with this. First place where we're headed is to more space. And so we see 2 minus 2 cosine theta, and we say, all right, I can factor out a 2. And by the way, if you're ever asked to justify a step, factoring isn't really the name of a step. The name of the property that lets us factor out a GCF is a property you've all heard many times before. It's the distributive property. So if you're ever asked to justify a step like that, use the name distributive property. Normally we think of distributive property going the other way, but the whole point of properties is that they go both ways. Well, 1 minus cosine theta over 1 minus cosine theta cancels out. And there we have 2 times 1 over sine theta, which is 2 times cosecant theta. And hey, that is exactly what we were looking for. I know it took a long while to get there, but we have verified this identity too. And just to be clear, what we mean when we say we have verified identity is that means we have said that the sine of any angle divided by 1 minus the cosine of that angle plus 1 minus the cosine of that angle plus, over sine of that angle is equal to 2 times the cosecant of that angle. Well, that's quite a mouthful, but it'll be true for any angle on the planet. That is exactly equal to 2 times cosecant of x. They're the same thing. So when we've verified identity, we've proven that these are just two ways of saying the exact same kind of weird thing. We'll look at one more because it's a little bit different. So one of the skills that we had earlier in the year that we haven't really come back to much is factoring a difference of squares. Your job is to recognize that 1 minus the tangent to the fourth of x is a difference of 2 squares. And we did learn earlier in the year that the way you get a difference of 2 squares is by multiplying 2 conjugates. So I'll build my wall here, and I'm going to turn 1 minus tangent to the fourth of x into 1 plus tangent squared of x times 1 minus tangent squared of x. Now, 1 plus tangent squared of x, we know that that is secant squared of x. Be careful about 1 minus tangent squared of x. It is not anything. There's really nothing useful to do to that. I know it's so tempting to say, oh, that's just the opposite, so it's just negative secant of x squared of x. But no, it's not the opposite. If there was a negative sign in there, then that would be okay. But it's not. So secant squared of x times 1 minus tan squared of x. I certainly could keep going there if I wanted to, but I don't. So let's see what we can do on the other side. Well, one thing you might notice is that there is a secant squared of x that I can pull out. And that's really convenient because there's a secant squared of x on the right-hand side also. And so now we can at least see, like, hey, if we could just get those parentheses to equal each other, then we're good. Wow. 2 minus secant squared of x. It's tempting to use the Pythagorean identity there. If only that 2 were a 1. Well, it's very easy to make a 2 into a 1. All we have to do is split it up into 2 pieces. 2 is the same thing as 1 plus 1. So we've got 2 secant squared x times 1 plus 1 minus secant squared of x. And that one we'll leave alone. But this 1 minus secant squared of x, using our Pythagorean identities, that's equal to tangent squared of x. Sorry, it's equal to negative tangent squared of x. If you're not sure about that, it's always worth taking an extra second just to make sure, starting with your original Pythagorean identity. If we move the secant squared x to the left-hand side, we'd be moving the tangent squared x to the right-hand side, so we'd be subtracting from both sides. 1 minus secant squared x, and subtract the tangent squared of x. And hey, that's what we got. So what you want to do is make sure you finish your last line by actually writing it out as one single statement. The secant squared of x times 1 minus tan squared of x is equal to the secant squared of x times 1 minus tan squared of x. And then we're done.